Hello and welcome to the first lesson of the Predictive Modeling Fundamentals 1 class. This is lesson 1 and the introduction to our course. So, my name is Mikhail Akirevich. I'm a product marketing manager with IBM Predictive Analytics, and I'm joined by Armand Ruiz, who is the product manager for IBM Predictive Analytics. So, in today's class, we will set the stage for what we're going to be talking about for the remainder of the course. We'll do an introduction to data mining and how it applies to business problems. And we'll discuss the software tools, the SPSS modeler tool that we will be using throughout the course. So after the session, you'll be able to, have a better understanding of what data mining is and what it isn't, understand the CRISP-DM methodology, which we will get into later, and then you will start accessing and exploring around the SPSS modeler workbench. So again, the agenda for today, we just covered the course overview. We're going to dive into data mining, followed up by CRISP-DM. Then we'll do an introduction to SPSS modeler, and then after that, the next step will be our first lab, which is installation of SPSS modeler trial and, taking the first steps with it. And then there will be an opportunity for you to review the lab solution. So just to put things in perspective and to understand why we are doing this now, why we're delivering this course, why there's so many courses on predictive analytics, on data mining popping up all over, is the fact that data is being generated at an astounding rate, and it's becoming cheaper and cheaper to generate it and collect it. But once you have all this data, the question becomes is how do you extract insights from it, and how do you convert that data into value? And analytics, they already are driving decision-making for many organizations, and 7 in 10 business leaders say that insights are integral to their decision-making. And with time, the investment and the focus on analytics and expanded usage of analytics is only going to grow. So data mining. So what is data mining? We're in the information age and a lot of data is available. So the question becomes, how do we consume this data? How do we translate this data into information, make it usable? How do we derive insights from it? And that is what data mining is. It's the process of discovering insights, hidden patterns, trends, and relationships from data. And we can extract various types of knowledge from the data. So we can do descriptive analytics, which is, what has happened and why did it happen. This is basically business intelligence. And then there's predictive analytics. With the data, what is likely to happen next? And this is what's going to be the focus of our course. So what are some of the things that we can learn? What are the common types of algorithms that predictive analytics kind of separates into? So there's association rules, which are rules that indicate relationships. For example, people who buy diapers also buy beer. People who do X also do Y. Things happen in conjunction. So we can see how, for example, different product placements can work, how putting one product on sale can influence purchase of other products, which products go together. Then there's classification, which is finding a model that describes the data and classifies it into a set of categories. So, for example, you have a data on drivers and with their demographic information, with their driving habits, etc., and with past information of whether they were likely to drink and drive or not, what did they do it or not. So with this information, we can identify what properties make a person more likely to drink and drive. And if we look at a new person who we haven't seen before, is this person going to be likely to drink and drive or not? And then there's segmentation, which is we're grouping people by similarity. We don't know what these people have done in the past, so we don't have a particular variable on which we're segmenting them on, but we are breaking them up into clusters based on their similarity amongst each other. For example, you can have suburban families with children, single college students, urban empty nesters, etc. So why is data mining important again? Well, it is a function agnostic and industry agnostic tool and process, and it can help organizations derive value regardless of what their focus is and regardless of what the users of data mining do within the organization. They can focus on marketing and attract and grow and retain their customers. They can optimize operations. They can find out instances of threat and fraud. They can help manage risk, etc. So data mining is prevalent to the entire business cycle, and it can make a positive impact on the organization regardless what industry it's in and what function it's implemented in. So what is data mining and what it's not? Well, the key thing about data mining is that it allows us to uncover information and insights that are hidden. So, for example, dividing up customers of a company according to their gender, well, that's not data mining because we have this information in front of us. Computing total sales of a company, that's just aggregation. Again, no new information is created. If we store a student database, that's not data mining, nothing new happens. Predicting the outcome of tossing of a fair pair of die, well, it may seem like it's data mining because it has predicting in it, but truth of the matter is, if it's a fair die, then every outcome has the same probability. So really no new information gets uncovered. But if we're looking at predicting future stock price of a company using historical records with time series, that's data mining. Or if we're looking to group customers by their similarity, that's also a data mining process. So when we're looking at predictive models and data mining algorithms, they help us, they create predictive models by analyzing the data to, find the patterns within it to help us extract insights. And then the models that we derive from the algorithms, they then contain the parameters that we've uncovered, that we've identified, and then we use them to make predictions about future cases. So some of the cases is customers that are likely to churn, which customers are more high value, what's going to be the credit risk score, is a tumor likely to be malignant or benign. So these are the questions that we evaluate, and an algorithm runs on a set of historic data, and then a predictive model is generated with parameters, and then that predictive model can be applied to a new instance of data that we haven't seen before and make a prediction about, an outcome. So the data mining process that SPSS Modeler uses, and that is, a widely used in the industry, is the CRISP-DM process, the cross-industry process for data mining. So it's an iterative process, continuously learns and improves through accumulation of insight and predictive power. So it doesn't just go once in a straight line, it goes in a circle and continuously updates, and as you update one step of it, you may have to go back and update a previous step. And it's comprised of the following, key steps. The first one is business understanding, and the question is, what should be accomplished from a business perspective? The next one is data understanding, acquiring the data needed to accomplish the objective. The next one is data preparation. Once we understand the data, selecting and cleaning the data. That's the process. Then we may transform it, aggregate it for analysis, and prepare it for modeling. The next one is the modeling stage, where we select the technique, build and train the model, assess its accuracy. Then in the evaluation stage, we see whether the model we've built meets our business objectives. And then finally, the deployment stage is the strategy around actually deploying the model into the business. And the tool that we'll be using throughout the course is IBM SPSS Modeler. So what you're looking at right now, the screenshot, that's the Modeler workbench, and it's a comprehensive predictive analytics platform, and it's designed to bring predictive intelligence to decisions made by, it can be individuals or groups or systems, the enterprise, and the good thing about it scales from desktop deployments to integration with an operational system, provides a range of advanced analytics, including text analytics and entity analytics, social network analysis, decision management, and optimization. And it's built with the business user in mind, so marketers and analysts, they can use it, and they don't need to run complex algorithms or scripts. They don't need to know how to do that. You don't have to be a programmer to use SPSS Modeler. For those who want to take advantage of the more complex tools or customization options, that's obviously available. And Modeler integrates well with open source software, for example, R. And there's a ton of strong and powerful data manipulation and algorithms available. We'll be reviewing more of them later through the course. But just to give an example, there's we can do churn analysis, we can do geospatial analysis, there's support vector machines, there's various kinds of association algorithms. So it's a really, really powerful and comprehensive workbench. So in the next step of this lesson, we'll be going on to actually doing a lab. And in the lab, we'll install the Modeler workbench and see how it actually works. So thank you, and we'll see you in the next lesson.